In this video, we've been asked to find the determinant and the trace of the following matrix A. And if we notice, they've mentioned two important terms, which is the determinant and the trace. So the first thing we need to do is actually understand what the determinant of a matrix is and what the trace of a matrix is. So that's how it can be represented. So the determinant is simply a property of a matrix that tells us if a matrix is a singular matrix. When a matrix is singular, meaning that the determinant is 0, right? So this determinant simply helps us to classify a matrix under a certain category. And if a matrix is singular, then the determinant is 0. And the question might be, given that a matrix A is singular, find the value of AB or something of that sort. In that case, you already know that the properties, the determinant will be equated to 0. Now, if a determinant is, if a matrix has a non-zero determinant, then it is invertible, right? That's the property. So that's something you have to know. It's either a matrix is singular meaning that the determinant is 0, or it's invertible meaning that the determinant of that matrix is different from 0. So that's it. That's all you need to know. And we're going to see later in the video how to actually compute the determinant of a given matrix, generally a square matrix. Now the trace of a matrix is simply the sum of all elements in the leading diagonal. Very easy. In the leading diagonal. So in this case, what do we know? The leading diagonal here. So if we consider a matrix A, right? This is our matrix A, and these are the various elements. Then these are the leading diagonal. These are the elements on the leading diagonal. So simply the trace of the matrix, right, will simply be the trace of A will simply be 3 plus 1 minus 2, which is 2. Yeah, so that's it. So the most important thing, or the most challenging one, is actually to compute the determinant. So to compute the determinant of A, generally represented as the depth of A, there are a couple of things we need to keep in mind. So the first thing, when computing the determinant, let me just create this space here. Now when computing the determinant, we need to have in mind the parity matrix. So to be honest, I don't know if this is the correct name, but the parity matrix, right? We have to follow the parity matrix. So this is a matrix of this form. So you need to follow this matrix, meaning that the first row, second column will be negative. The third row, the first row, third column will be positive, and so on. So you just need to pay attention to all of these. And when we are given a matrix, and in this case A to be 3, 3, negative 1, 4, 1, 3, 1, minus 2, minus 2. Consider the first element and the parity of the first element. In this case, the parity is positive, right? And this parity here, so it's positive. So this will simply be 3, right? Now, when we consider this first matrix and the parity, which is plus 3, we are going to draw a cross here. This cross simply isolates the elements that we are not going to consider. So this will be like a subdeterminant of a 3 by 3 matrix. So it's like we're breaking down the 3 by 3 into a 2 by 2, and from there we can get the determinant. So the subdeterminant of the submatrix of the element 3 is 1, 3, negative 2, negative 2. Now once we are done, we go to the next element. In this case, our next element is 3, right? And the parity here is minus. And if the parity is minus, then we are going to consider the number 3 and also the parity. And then the submatrix will simply be 4, 3, 1, minus 2. And finally, we go to our next element, which is negative 1, and we also consider the parity. So our next element is -1, and the parity here is, actually plus, so we just maintain the negative, and the sub matrix will simply be 4 1 1 minus 2. So that's it, as easy as that. So you can apply the same idea considering the first column instead. So considering this and following the same rules like that, that is following the parities here, you can also consider this and you follow this parity here. You can consider this, follow this parity, or consider actually this and follow the same parity. So it's very flexible, you can do whatever you want, and at the end you should have the same result. But in this case, right, we've considered this, so we've considered the parity horizontally, and that's how you should pay attention to. If you're considering the parity matrix that is horizontally, you should also consider the same rule of the matrix you're looking for the determinant. So this is very, very important property to pay attention to. So yes, this is what we have. So what we simply need to do is to calculate our determinant of a 2 by 2 matrix. So we know that if we have a matrix M equal to A, B, C, D, right, then the determinant of M will simply be AD minus CB. So like you take the product of the leading diagonal minus the product of the non-leading diagonal. So that's what we're going to do for all of these matrices. So this will be 3 bracket 1 multiplied by -2. We're going to have -2 minus, remember there's a minus in the formula, -2 multiplied by 3 is -6, right? -3, we're done with this, we're here. Then -3, 4 multiplied by -2 is -8, right? Minus, remember the sign. 1 multiplied by 3 is 3. We're done with this. Finally, -1. 4 multiplied by -2 is -8. Minus 1 multiplied by 1 is 1. We simplify our result. So this will be 3 into -2 plus 6 minus 3 into, this will be -11, I believe, minus 1 into -9. And here we're going to have 3 into, this will simply be 4. This will be plus 33, and this will be plus 9. And here will be 12 plus 33 plus 9. And if you take 1 from here, add here becomes 10. So this will be 21, 33, which will be 54. So the determinant of A is 54. So that's what was required for this question. As simple as that. So you just have to pay attention to that. The parity matrix, especially when computing the determinant, if you miss out these signs, you're going to get a different value completely. So that's it for this video, and I hope it was helpful. See you in the next video.